So hello everyone, here I am again. I'm Miss Rayame A. Ramirez, and now in this video we will going to talk about geometric transformations. So to recall, there are three geometric transformations. Those are translation, reflection, and rotation. However, we will start and just focus in only one of those. So basically, it is all about the translation that we're going to dig up today.
So what is translation? Translation in the coordinate plane is a geometric transformation that involves moving a figure or point from one location to another without changing its size, shape, or orientation. It is commonly referred to as a slide or shift operation. So step 1. Identify the original figure and its coordinates. So here, let's consider a triangle with vertices A with coordinates 2 and 3, B with coordinates 4 and 5, and C with coordinates 6 and 2. So these are the original coordinates, and we will must plot these first before we proceed to the next step. Here, we draw a coordinate plane. So, the point A, it has coordinates 2 and 3. So, it is more or less over here. 2, 3. Point A. Point B, it has coordinates 4 and 5. 4 and 5. It is more or less over here. Point B. So, in point C, it has coordinates 6 and 2. 6 and 2. It's more or less over here. So let's connect the points. So this is the original figure. So what we're going to do next is to determine the translation vector. So the translation vector represents the distance and direction of the movement in the coordinate plane. So you can define the translation vector by specifying how much you want to move the figure horizontally, left or right, and vertically, up or down. So for example, in this case, if you want to move the triangle 7 units to the left, 7 units to the left, and 6 units down, 6 units down. So the translation vector here would be -7, -6. So that is the step 2. So in the next step, we will apply the translation vector to each coordinate. So to translate each vertex of the original figure, add the corresponding components of the translation vector to the original coordinates. So the original coordinates of point A are 2 and 3. Then we'll add the translation vector -7, -6. This will result to the new coordinates of point A. So 2 plus -7 equals -5, and 3 plus -6 equals -3. So, same as with point B, it has coordinates 4 and 5. We will add the translation vector -7, -6. This will result to the new coordinates of point B. So, 4 plus -7 equals -3. 5 plus -6 equals -1. So, the same process with point C, it has coordinates 6 and 2, plus the translation vector, -7, -6. This will result to the new coordinates of point C. 6 plus -7 equals -1. 2 plus -6 equals -4. So these are the new coordinates of the triangle. So we will proceed to the next step. We will plot the translated figure. So once you have computed the new coordinates for each vertex, plot them on the coordinate plane to form the translated figure. So here, the new coordinates of point A are -5 and -3. So we'll plot this. -5 and -3. So more or less it is over here. It is the new coordinates of point A. So in the new coordinates of point B, -3 and -1, -3 and -1 is more or less over here. B prime. And lastly, the new coordinates of point C, -1 and -4. So -1 and -4. It is more or less over here, and then we will connect the points. Oh, this is C prime. So this is already the new figure. It is in quadrant 3. The original figure is in quadrant 1. So as you can see, the original figure in quadrant 1, it moves 7 units to the left, 7 units to the left, and then 6 units down. So it is in quadrant 3. So the last step is to verify the translation. So to confirm that the translation was performed correctly, check if the size, shape, and orientation of the original figure remain unchanged in the translated figure. So that's it. So by following these steps, so you can perform a translation in the coordinate plane. So remember that translations can be performed on any shape or figure, not just triangles, and follow the same principles.